Hi, I'm Bob Pryor. I'm talking to you today about graphing parabolas, but especially it's a preparation for graphing trig functions. We're going to look at some features of graphing parabolas to help us understand how to graph sine and cosine. First of all, let's look at some aids for graphing, in particular increasing and decreasing functions. We talk about linear functions, which is another name for lines, and lines either increase or decrease as we go from left to right. We always read from left to right. And it's the slope of a line that will determine whether it increases or decreases. We can see with the slope m is greater than 0 or positive, the line increases. And when the slope m is negative, it decreases. If the slope is 0, then the line neither increases nor decreases. But we can use this in non-linear functions, curves. As we see here, here are 3 different curves that increase and then 3 other different curves that decrease. And again, always read from left to right. Actually, many curves do both. On a certain interval, they will decrease and then increase, or maybe increase then decrease. When we have a function that both increases and decreases, either we get a highest point called a maximum, as you see here, will increase to a certain level, then decrease, there's the maximum, that single point. Or we might get a lowest point where we decrease first, or the graph decreases, and then increases, and that's called a minimum. We'll find that sine and cosine have maximums and minimums, called maxima and minima. We'll talk about that later. Okay, let's talk about concavity of a curve. Here's an informal description below, but basically what we do is we shade the side either above or below the function that the function is bending toward. The shaded region is below the curve, then the function is concave downward, or if the shaded region is above the curve, then the function is concave upward on an interval. Let's take a look at some examples. I put a dot below each curve just to kind of give us a point of reference. But each of these on the left, shaded in blue, are shading above because the curve is kind of bending toward above or away from that point, actually, from that point that's below. So these all have upward concavity. In the next group, again, I put a dot below, but they're all bending toward the dot. They're all bending downward. So all of these have downward concavity. Now a line has no concavity, no curvature. That's another name for concavity. Sometimes on an interval, a graph will have both upward concavity and downward concavity. And there's a particular point where it changes called the point of inflection. In this graph, we had upward concavity and then downward. In the next graph, we have downward concavity first, then upward concavity, and it changes at a single point, again called the point of inflection. Sine and cosine graphs have a lot of concavity and lots of points of inflection. So, looking at graphing parabolas in general, we're going to start with what many people call the parent function. It's f of x equals x squared. There's nothing attached to the x squared, just f of x equals x squared. And you can see here, we've got different x values that I've chosen here. X is 0, and we put 0 squared, we get 0, and we have the ordered pair 0, 0. We have the ordered pair 1, 1. When we put negative 1 into the function and square it, it's also 1, so we get negative 1, 1. 2 and negative 2, both squared, give 4. So those two ordered pairs are across from each other. And the same is true for negative 3 and positive 3. They both give 9 when they're squared. What we have here is a graph that is very symmetric about the y-axis. And so we call the y-axis in this case the line of symmetry, sometimes referred to as the axis of symmetry. And the very bottom point is called the vertex, and it's on the line of symmetry. Notice in blue, I've indicated that at the points 3, 9 and negative 3, 9 are both 3 away from that line of symmetry. 3 to the right, 3 to the left. And the negative 2, 4 and positive 2, 4 are both 2 away from the line of symmetry. Basically, what we see is that in a parabola, we have these symmetric partners, kind of symmetric pairs also. 3 and negative 3 are partners, 2 and negative 2, and 1 and negative 1 are partners. Notice, though, that 0 is the only one that has no symmetric partner. And that's actually important information that we'll see in a little bit. All right, now let's talk about a vertical shift. Vertical means up and down. So it's taking the parent function, x squared, and shifting it upward or downward. That means adding a constant outside of the parent function, in this case, plus 3. Notice it's written after the x squared. And when we do all those calculations, the plus 3 is always after whatever number is being squared. On the graph, we can see those points being plotted. And there in red is our line or axis of symmetry. Again, what we can do with those, though, is we can find their symmetric partners. Here we see negative 1, 4 is a partner of positive 1, 4. And 2 away to the right and 2 away to the left give negative 2, 7 on the left side. That means that we don't need to find all the points to graph the parabola. We're going to discover that the same is true when graphing sine and cosine. We don't need to list all of the points, just some of the ones that are important. All right, next is a horizontal shift. Horizontal means left and right, so it's going to shift a graph to the left or to the right. And we can tell that there's a horizontal shift in the function when there's a number added or subtracted directly to the argument, the x plus 5, inside the function. And it's going to indicate the amount of direction of horizontal shift. So the way we do that is to set the argument equal to 0. Take that whole x plus 5, set it equal to 0, and solve. X equals negative 5. That tells us where to start our x values when we choose x values to put into the function. You see we're starting at negative 5, and we get 0, negative 5, 0. And we can locate that point in the xy plane. Notice, and this is going to end up being the vertex, it has been shifted from the origin, 0, 0. And now we'll try negative 4, and we'll also do negative 3 and negative 2 and find those ordered pairs. What we're going to find is as we plot these points, we're going to plot just the right side. Then we'll identify the line of symmetry, and then using the line of symmetry, we'll get the left side points. Again, all of these points are occurring just like they would on the parent function, except that they're all shifted 5 to the left. There's the line of symmetry, and one at a time. The negative 4, 1 is 1 away to the right. So we go 1 away to the left. At negative 6, 1, there's another point on the curve. Same thing for negative 3, 4. 2 away to the right, 2 away to the left to get negative 7, 4. And at 9, 3 to the right and 3 to the left to get negative 8, 9. And now we have enough information for us to draw the graph. It's not beautiful, but you know how it is. Again, notice that this is the only point, the vertex, that has no symmetric partner. All right, the last feature that I want to talk about today is reflection about the x-axis. You'll notice that the function this time is negative x squared, and that means the coefficient of x squared is negative 1. Now we'll start again with 0. This is kind of going back to the parent function. The important thing to know is the negative is actually not being squared. We don't see that so much with 0, 0. But with 1, notice when we put 1 into the function, we're negating 1 squared. That gives us the negation of 1, or negative 1. And that point is actually below the x-axis. When we put 2 in, again, we're going to be negating 2 squared. So it's the -4, another point below the x-axis. And I think you can see how the graph is going. Putting in 3, we're getting in the negative of 3 squared, -9. And once we plot those points, we'll be able to identify the line of symmetry. And you'll notice that the origin 0, 0 is the vertex, and it's on the line of symmetry. And then we can use the line of symmetry to find points on the left side. Going 1 away to the right, 1 to the left, and now 2 away to the right and left. And at 3, -9, 3 to the right, 3 to the left. And now we have enough points to be able to draw the parabola. All right. Well, I hope this has been helpful to you, and it's getting us prepared again to graph sine and cosine. So we'll see that soon. Take care.